Hello, everyone. So today I'm gonna come to chapter 3. And in this chapter 3, we will chapter 3, we will only use numerical. We will use numerical data. Okay. So what did we talk in chapter 1? Say chapter 1. We have talked about categorical data, and also in chapter 2, we also have categorical data. And now in chapter 3, we focus on numerical data, right? Which is the data that's basically for number. Okay, so what is goals for section 3.1? So section 2.1, we're gonna try to summarize for symmetric distribution. So keep in mind that in this section we focus on symmetric distribution, which is like a bell shape as symmetric distribution, right? And the center or typicals of we're going to focus on how to measure of center and spread of symmetry and bell shape distribution, which is using mean and standard deviation, right? So what is a mean? Okay, so mean, I mean, just remind you from I did talk a little bit about it in chapter 2. Mean is actually average, right? Mean is average in this course, average. Okay. And for mean, a collection of data is represent the typical value in a symmetric distribution. So the formulas for finding the mean or average is sum of all data values divided by number data value. And the notation that we are using was in this one, as you know, the notation there we call like sum of all the data, right? The sum, okay. And the n there is number of data values. So we also want to talk, we will also want to have the symbol with the X bar there. It's going to be the sample mean. Okay, sample mean is a mean or the average of a sample. Another notation or symbol that you might think about is in the future is the average for the population, like a whole population that we are doing research, right? So so one is for sample and another one is for population. I'll use other color to make sure it's different. Okay, so they are different. Yeah. All right, so let me have like a box in here. Okay, so tables. So all right. So in this chapter, in 3.1 to 3.2, we're gonna focus on symmetric. Okay, symmetric. Okay, and we also have like a center spread as mean and standard deviation. So standard deviation, I'm gonna use the notation as ST. Oh, sorry, STDV. Okay. For 3.3 to 3.5. 3.3, 3.3, 4, and 3.5. So I'm gonna say 3.3 to 3.5. We're gonna learn about school distribution. So it could be the school to the left or school or school to the right. So so I have talked about it in chapter 2 sometime, right? For center of school, we're gonna focus on using median. And spread will be the IQR, like inter quartile range. Okay, I'm gonna talk about that more later, but yes, for now this is strategy for this chapter. Okay. All right, so let's start with some technologies by using calculators for finding mean and standard deviation on the calculators, right? So I specifically will say could be like TI 83 or TI 84 is going to be the best. But you know, I have only software with TI 83 over here, right? Yeah, so that's gonna be really helpful for you to find mean and standard deviation on calculators. By the way, I also will help you to use that crunch to handle these two things. Okay. So I have like deeply instruction here for you to follows, but you know, we need some data, right? We can use the example 1 here as the data that we collect from a sample of 6 quizzes score. Okay, and then we want to find the mean and the standard deviation, right? So let's move up a little bit. Okay, so okay, right here. All right. So let's see. I'm gonna start. Click on the start. I go to the. I'm gonna have choose cal C here or calculate. All right, and then I choose one VR stats. Okay, so I enter. By the way, I forgot to input the data. So I must start by input the data as edit here. I mean, yeah, for this step, I haven't show you the step that input the data. So let me type it in here for you. Say step 0, press start and then edit and then input the data value in list L1. So let's follow that and then see what happens. Okay, so let me quit this and then start, edit, Okay, so put down 28, 24, 30, 20, 19, 27. Okay, so this is the 6 quizzes score that I have, right? And I'm using the TI-83. Okay, so I click start again. So start. And then I move my highlight to the calc C there, right? And then enter 1 as 1 VR starts here. So enter that. And then it's default as L1, but I mean to be specific, I'm gonna use L1. I'm gonna put L1 here by second and number 1, which is L1, the 0, 1. The 0 button here just help you to use for the zeros option here. Okay, so it's L1. So we got L1 here, right? And then enter. So it's right away appear like the output of all the data from all the data values that you did collect. And keep in mind that they say over here the X bar is sample mean, SX is sample standard deviation. So we are trying to find these two first. So I'm gonna focus on just look at these two. So I got like X bar is 24.67 as 2 decimal place, and then the standard deviation sample here is SX is 4.46 at 2 decimal place. So I'm gonna write out those, right? So X bar will have to be equal to 24.6667, and then the mean and then the SX will be 4.46. SX will be equal to 4.46. Yeah. Okay, so let's compute the mean by hand and see if that's going to be the same, right? So you have say sum. So X bar will be equal to sum of all the X divided by N. So which is you adding 28 plus 24 plus 30 plus 20 plus 19 plus 27, right? And then everything you divide by N, which is 6. 1, 2, 3, 4, 5, 6. 6 number, right? You're gonna use a calculator, and I'm pretty sure it's must be equal to 24.67. Okay, so that is a way we do by hand. Okay, and I just show you by calculator, so it should be 24.67. Okay. Okay. So for using calculators, make sure that follow the highlight that I told you, right? You need to know the start button, the count C button, the stats option. All right, so okay. So we're done with B, and what part C I can say, use a complete sentence to interpret. So interpret the mean in context of this problem. So we say the typical typical in here is the center, right? So center. So center. The center of the quiz score, right? Center quiz score. What's valuable here is quiz score. Quiz score. Oh, come on. Was mean was 24.67, right? What's the unit of this variable? Just point, right? Right. Okay. So that's gonna be it for example 1, right? Okay. So let's move to example 2. So this is a sample of height in inches. A female student in a stat class that I have collected before. So I mean, as you see before, if you have like a few data values like 6, then you can compute by hand easily for me, right? But for some case such as like, you know, more than 10 or even like more than that, I don't think it's a good idea to use hand computing, right? So so we're gonna just using calculator to handle the sample mean for math for this example, right? So first, I'm gonna quit this, right? Clear this, make sure. Okay. First, you're gonna click start, right? You need to input the data collection, right? You just put down 65, 68, 66, 66, 63, 65, 66, 62, 66, 68, 66, 64, 64, 72, 63, 60, 66, 69. Okay. So as you can see right now, so I have in here say L1 19, which means if you have like the 19th data values you input here, but actually we have only 18, so we stop right here, right? So I want to make sure it was 18 data, and you can check with like you can recount this to make sure that you don't miss anyone, right? Okay, so after that you're gonna click on start and then cal C, right? Move to cal C here. One VAR stats, all right? And then that. And then, you know, and then just hit L1. Nice. Okay, so you right way get the answer will be 65.5 as the mean. Sample mean, right? 65.5. Okay. So what do you want to say for interpret it mean? So the typical or the mean, right? Again, the mean, the average, right? Of height. Of females, because it is a female student. In a stat class, right? Was 65.5. And what's in it? That make sure that we say in inch, right? So inch. Okay. So that's gonna be it. So the idea of mean is the balancing point of distribution data. Okay. All right. So for symmetric data, the mean or the typical values and balancing point are all the same. Right? In symmetric data, usually it's going to be in the mode in the highest over here. Approximately it's going to be around here, right? Okay, so what about for the school data? Right, school data. What about that? I'm going to use other color. The mean and balancing point are the same. Okay, but the mean is not the typical value anymore, because you can see that the means for school is around here, right? Okay. Okay. So let's move to standard deviation and see what's going on. So again, what is standard deviation? Standard deviation is a tool to measure the spread of the data, right? How it's spread out, right? So so this is the measure of spread, right? A way to see if most observations are close to or far from the typical values. Okay. And standard deviation, sometimes I use STDV or SD. So I mean, sometimes you see SD, you can just understand that, I mean, is a standard deviation. So standard deviation of a collection data can be can represent the typical distance of data. It represent the typical distance of data value far from the mean in a symmetric distribution. Okay, in a symmetric distribution. Okay. And is can be calculated by using the formula as square root of sum of the value that's minus the sample mean there and squared, and then divided by sample size or the number of data values minus 1, right? And the symbolize was using S as sample standard deviation. For populations, okay, for population, you will use the sigma. Okay, so in this chapter, we focus on using the sample only. Okay, and later we're gonna use population standard deviation. Okay. So how to interpret the standard deviation? Okay. Interpret. I'm gonna use pink color here. Okay. The majority of observations, about say about 2/3 or 68%. Right. The majority is kind of like, you know, like most main of all the data. values, it stay in about 2/3 or 68% in the data set, and with is with one standard deviation of the mean. Okay, so it could be one above or one below. Okay, we're gonna talk more about that in the empirical rule later. Okay, so but usually when in order to interpret the standard deviation, you want to just say the majority of the observation is about 68% in data set within one standard deviation of the mean. So let's do an example and see how we handle the standard deviation and interpret it, right? So let me use other color. Say below is sample of 6 squids again, right? Yeah, and I think we did it by our calculators from example number 1. I'm not sure, right? 28, 24, 30, 20, 19, 17 here, and I got the standard deviation was 4.46. Okay, by using calculator, right? Okay, so I'm gonna show you again to make sure that where it is. Okay, so I'm gonna clear everything and click on start. I need to enter or edit the input. So 28, 24, 30, 20, 19, 27, right? And you saw that I still have some old data values from another example. I need to delete it. So delete it, delete, keep delete everything, please. Okay, you're done. And then now you can just click start, go to Cal C, one VAR start, enter. You can enter one more time for default, but I just want to make sure, so I put L1 as specifically. So you have to look as the SX, this guy. Let me using my annotate here in case you need it. Okay, so I want to focus on the SX here, which is the standard deviation 4.46 at 2 decimal place. Okay, so I'm gonna just using that. So SX equal to 4.46. Okay. So by using TI 83 with one VAR start, right? Yeah. All right, so we move to part B. Okay, so after we found after finding the standard deviation, right? Let me highlight it by using calculator. We're gonna try to interpret it. Okay, try to interpret it. So we will say the majority, or roughly 68% of the what of the observation. What is this observation here? Quiz score, right? Of the quiz score. What time? Quiz score, right? It's gonna be within. So what? How many? What is standard deviation in here? 4.46, right? 4.46. And what's the unit of that of the variables? It's gonna be the point, right? And then of the mean, right? Of the mean quiz score. And what's the mean value? 20 I forgot. 20 it was 24.67, right? So this is the this is option number 1 to say, right? Option 1. You say that majority, roughly 68% of the quiz score are within 4.46 points of the mean quiz score of 24.67 points. Another way to say, I think this, I like this way better because it's shorter. So say option 2. This is the majority of what the variable is here? Quiz score, right? Sorry. Quiz score. The majority of quiz score is formed between 24. Oh, sorry. I mean, you can do like 24 point. Oh, let's make this more here. Between actually it's in here. I'm gonna do like outside limit 24.67 and then minus for what is standard deviation in here 4.46. So what is that equal to? 20.21. Yeah. So I will say like 20. I'm gonna put like 20.21 in here, and then here maybe work sign, and then use another one as 24.67 and add with it. So add with 4.46. That's gonna give you 29.1 3. Okay. So yeah. Okay. So for the other side, you're gonna say 29.13. Yeah, and the units gonna be just part. Yeah. So it's majority of the quiz score is fall between like 20.21 to 29.13 points. Okay. Okay, so now I'm gonna move down to the next one. But I mean, I think I'm gonna just go ahead and draw you a rough graph of the symmetry for this case. And you could think about mean is always in the middle, which is 24.67, right? And then if you subtract one standard deviation, you will get here as 20.21, and you adding one standard deviation, you will get 229.13 here. So the area, oops, sorry, the area under the curve in between 20.21 to 29.13 will be the majority of the quiz score, which costs around 68% of all the data. Okay. So let's move on to the next example. We come back with the example that talking about the height of the female student, right? Okay, so I would love to let you guys to handle these examples in a few minutes and then check with my answer key after that. Okay, so I'm gonna pause. You should pause and then pause the video and then when you finish you're gonna click play to see the answer key, right? All right, so here is the way I did and then get the answer. So as you practice, I just show you the way to calculate the standard deviation by using calculators, right? And by using calculators, you should get the sample standard deviation is 2.75. And for the majorities, I mean, for the interprets of the meaning of the standard deviation, you will say the majority of the height of female students are within 2.75 inches of the mean height of 65.5 inches. Or in another option, you will say majority of the height of female student fall between 62.75 and 68.25 inches. Okay, so that's gonna be it for this example 4. Okay, now we move to example number 5 and try to figure out which histogram. So these are all histogram, okay? To keep remind everyone who still like still trying to figure out what is histogram picture is. So here is some histogram examples that we can look at. And we want to know which histogram group have a larger standard deviation, okay? So let's take a look in between the two histogram in example 5 here. As you can see that the majority, let's say the mean of this or the typical of this could be around, I will say around here. Okay, right? And then so if you like if you say 68% of the value of the data value should be, I'm gonna say roughly, so just estimately, okay? Because we from the graph you can only like roughly estimate it's gonna be about like from here if you subtract one standard deviation, right? Say subtract one standard deviation and then you adding one standard deviation, this could be around maybe around here. All right, and that's gonna be like about 68% of the all data, right? So so what about the second one? I would say the second one, the means should be around this guy. So here, right? And and you see it's skinny, so you 68% of all the rest should be around, let's say around here to here, right? So 68%. So you can see that the standard deviations comparing, say, in between to this, you can clearly see the first one has more spread out. So let me type. This one have more spread out, right? And I mean, in chapter 2, I did mention about like about it, but now in chapter 3 already, we, instead of just saying more spread out, we can just say standard deviation is large. Okay. Yeah. For the second one, I'm gonna say more close together, right? More close together, right? They just get close together, so more closer together. Okay, let's see that. And in this chapter, for now, you can, instead of saying that, you can just say standard deviation is small. Okay. So that's from the histogram in chapter 5 we can say about standard deviation, right? Let's move to example number 6. We're gonna try to put the following in order from smallest standard deviation to largest. Okay. So think about 68% of these in estimate. You will, I mean, I would say, because you know it's the first one was by models. You will have to maybe use the one from the first to the one from the last. So say 68% might be around here. Okay, would be around here, and the middles over here as a mean. So 68% will be around that. For the one but B over here, it is uniform model, so everything's look like the same. You can just use from the second bar to the fifth bar, finishing fifth bar, right? Gonna be 68%, and the mean should be around here, middle. So for the last one, it is roughly symmetric. You can just use the first two here and 68%, right? Because it's focused in the middle. So so clearly I would say the last one, C here, have smallest standard deviation, and the data is get together. Okay. Closely. For compare, I mean, for the highest standard deviation, I would say, or the largest one, I would say the A here, because it, as you see, is spread from the first bar and the last bar, right? It's spread out. So I'm gonna say the largest standard deviation. And then gonna be second, I would say data is spread out. Data is spread out. Okay. All right. So you can, using the arrows, smallest to largest. Fine. All right. So we're gonna move to the next example and see. In this example, we have the data show. The data below show the monthly temperature in Fahrenheit of Raleigh and San Francisco. So okay. This temperature is reported by like 1 year, and each month we do the temperature, right? We report temperature of each month from January to December. So okay, so what the question? Because we say for the following monthly temperature of Raleigh, compute and interpret the mean and standard deviation. Yeah. All right. So keep in mind that we just focus on the Raleigh temperature only. Okay. Now I'm gonna show you by using StatCrunch for this case. Let me see. 1 second. 1 second. No, actually, I think I'm gonna use the TI-84 for this one, and then I'm gonna make like another video using StatCrunch for you guys to practice with that. Okay, so just gonna using the calculators for all this. So again, we need to enter the data value. So just put down all the values for Raleigh on L1, 39, 42. 50, 59, right? And then 67, 74, 78, 77, 71, 60, 51, 43. So that's 12 data values for 4 months, right? For L2, I'm gonna input all the data value for San Francisco. So let's do 49, 52, 53, 59, 58, 62, 63, 64, 65, 61, 55, 49. Okay, so after input everything, right? I want to make sure that L1 in here is stand for Raleigh, L2 is stand for San Francisco data value. So I'm gonna click start, calculate. Okay, I'll see you here. All right. We're gonna focus on one VAR start. So click one VAR start, and we calculate for Raleigh is L1. So click L1 in here. Okay, enter that. So right away I get the sample mean is 59.25. And right, and the sample standard deviation is 14.6 14.17 at 2 decimal place. So I'm gonna put out for me in here. I will say 59.25. Okay, that's X bar. Okay. Sample mean. Progress. For interpret the typical of what of temperature, right? Oh, man, I misspelled this. Of temperature in what? In Raleigh is 59.25. And in Fahrenheit, right? What is what about the standard deviations? It's gonna be S, then for the sample standard deviation is 14.17, 2 decimal place. And then say the majority roughly the majority is roughly 68% of the what of the temperature. In Raleigh are within 14 point sorry 17 14.17. My bad, let me do this. In Fahrenheit, the mean temperature of 59.25 Fahrenheit. Okay. And for part B, I would love to let you to pause the videos and then do it in 1 minute, maybe 2 minutes. After finish, you play a game, okay? So do it now. All right, so here is solution for part B. Okay, so check that with my answer key. Hopefully you all have the same. If not, please double check your answer. Basically, my answer is in 1 decimal place. It could be different with yours if you have 2 decimal place or more than that. All right, so let's move on. Now, we're gonna compare two mean. So the first mean was for the rally was 59.25. The second one is 57.5, right? So I would say like they're pretty similar, right? I would say both means pretty similar. So I would say the typical temperature in both cities similar. Okay, so that's could be the way to conclude for comparing between two means. What about the two standard deviations? So one is 5.8, another is 14.17. It's really different. I want to say like say rally have standard deviation is equal to 14.2, which is really greater than 5.8, which is the standard deviation of Samsung. All right. Standard deviation. Yep. So what we gonna say for this? The temperature in Raleigh varies more than temperature in San Francisco, right? So that is the way we compare the two standard deviation. In part B, say what is the range of monthly temperature of Raleigh from one standard deviation? So keep in mind that this is for Raleigh only, right? Below the mean to one standard deviation above the mean. So if I have a number line here, right? So the mean, let's say in the middle, gonna be what's that? I forgot. 59.25. Sorry. I want to change this one to be 2 decimal place in case. All right. Make it consistent, right? So this one was the sample mean. And then subtract 1 for the mean to get. So I subtract 14.17. You will get what is that? 59.25 minus for 14.17. What do you get? 45.08. Yep. Very high. Very high. And then if you adding 14.17, what do you get? Yeah, what do you get? So you do 59.25. And you might A plus with 14.17. You get 73.42. Very high. All right. So that means that 68% of temperature in Valley is fall between from 48 48.08 Fahrenheit to 73.42 Fahrenheit, right? 68%. Okay. Okay. Let's we move to some properties of mean and standard deviation. Okay, so probability of mean and standard deviation. For symmetric data, mean is the typical value, really. Yeah. And the standard deviations with S in here will measure the spread of the data. Okay. So if S equals 0 when all the data, I mean S equals 0 when all the data values are the same. Other than that, you have S going to be greater than 0, whereas S larger as the spread of the data increase. For the mean and standard deviation, mean and standard deviation, they have the same unit. Okay. And the mean and standard deviation are not resistant of the outline, resistant to the outline error. Okay. That is a strong skewness in few outlier can greatly change the mean and increase the standard deviation. And we will talk more about this in session 3.3. Okay. Now we move to variance. So variance is notation. So variance, let me use other color. Say red. Variance is actually standard deviation and squared. So that's the reason why you have the notation was going to be like S squared. And the unit will be square the unit from the standard deviation. Okay. Okay, so for the stat crunch reminder, in order to use stat crunch, I will also provide you a video. Keep in mind that it was in my Stella online homework, and you will follow by click the double box icon on the top right corner of the data, and then you open the stat crunch, open the stat, and then summarize that column and select data from column, select the statistics, and you will have mean and standard deviation for samples to find in order to find from stat crunch. And I will provide you videos for it after this. Okay. So I'm gonna stop 3.1 here, and I'm gonna move to 3.2 later, and see you in 3.2.